Okay, so this is my second video of my ISM project. And if you haven't watched the first video, please go ahead and watch it and answer the questions relating to that. And a brief overview of my project is that I've decided to go with the spins first method for introducing quantum mechanics. And this video specifically will cover spin and the Stern-Gerlach experiment. So the question arises, what is spin? So essentially what spin is just the angular momentum of elementary and composite particles. So elementary particles, they're just the 17 particles that comprise our standard model. The most famous of one is like probably electrons. Everyone knows that. And composite particles are just like protons and neutrons. And there's more of them, but like there's the two most well-known ones. And spin is just like an intrinsic property of these particles. So, and some important concepts for spin is that it's measured in units of h bar. And h bar is basically Planck's constant h divided by 2 pi. And a very important um, thing about spin is that it's quantized, which means that it is measured in discrete quantities like charge. The electron is the base unit for charge, 1.6 times 10 to the negative 19th coulombs. And all charge is multiple of the electron. And similarly, all spin is multiple, either a half integer or a full integer multiple of h bar. And it should be noted that spin can also be zero. An example is that the spin of an electron is either plus h bar over 2 or minus h bar over 2. And some more important concepts is that there are two states that a particle can be in, either spin up or spin down, and respectively they're denoted by the ket vectors plus for spin up and minus for spin down. And we'll cover more about ket vectors and bra vectors in the next video. And now onto measuring spin. So the way that we measure spin is through a Stern-Gerlach device. And through this experiment, the notion that the angular momentum or spin that is quantized was observed. And then due to this experiment, it was also discovered that the magnetic fields of particles were aligned with their axes, like the x, y, and z axes. So the experiment itself. So a scientist by the name of Otto Stern thought this experiment up in 1921, and Walter Gerlach completed this experiment successfully the next year. And the setup was as follows. A particle furnace was to send silver atoms through an inhomogeneous magnetic field. That just means that the force on one end of the magnetic pole will be greater in order to induce deflection, as you see here. You see how there's two streams of particles because the magnetic field is stronger on one side than the other. And then the particles that were deflected were recorded onto a screen. And what was observed was that the particles actually bunched up in two different places instead of evenly distributing like how it was classically predicted. And this concludes this video. Thank you for listening, and please complete the following questions in the Google form. The responses really help. Thank you.